Okay. So partial fraction decomp is very algebra intensive. Again, I said last time, don't let this section scare you. It starts off really hard, kind of difficult, and then the next section is pretty chill. Anyway, so what I'm going to do first is show you how to set up each case 1 through, I believe it's 5. And then we'll come back and solve them. Because the main, like 50% of the work is just setting it up. If you can do that, then you get most of the points on the exam. Solving it is the hardest part, but setting it up is super easy if you know what case it is, okay? So let's start with this guy right here. I'll write this down, and we'll go from there. Let me see what section that is. I think it's 9.4 or something, yeah. All right, partial fractions. All right, so case 1. Again, this is just a setup. We're not going to solve it. Distinct linear factors. So the first thing you need to do is factor, if it's not already factored for you, that's a 5, by the way. 5 over x squared plus x minus 6. So that'll be x. Well, actually, what do you guys think? What does this factor into? You guys remember, right?
X plus 3x minus 2?
Yeah, plus 3 minus 2. Now, do you agree that this factor, x plus 3, is linear? X minus 2 is also linear because there's no power of 2 or greater, right? Distinct meaning they are different. Since they are linear and distinct, the setup will be simply put a over the first factor plus b over the second factor. This is the setup for case 1. That's all you got to do. It does not matter what order you do this. You could put the b, or you could put a over x minus 2 if you wanted to. Just make sure that the b is over the other one. If you end up swapping it, the final answer will be the same. But if you're solving it, let's say you're working with a friend, right, and he puts a over x minus 2 and you put b over x plus 3. At the end, when you're solving it, your a's and b's will be different because you assign them differently. But the solution at the end should be the same. Okay. Just want to mention that because sometimes that causes a lot of confusion. All right, case 2. Pretty straight up, right? Setup is easy. Repeated linear factors. So here what we're going to do is combine case 1 with a repeated factor. So 2 x minus 3 over x cubed minus 2x squared plus x. That will be equal to this, right? That's x squared minus 2x plus 1. What does that factor into? This piece right here. this will factor into
X minus 1, X minus 1.
yeah, it's going to be a repeated. So this is where the rule changes from the case 1. All right, it's a 2. Now, x is linear, x minus 1 is not linear, but these are distinct factors, right? They're different. So technically, the first one will be a over x, the first factor, plus, and this is where it changes, you start with the highest power and you count down. Oops, sorry, you count up. So 1 and then 2. Does that setup make sense? So if you see a square or a cube, if you have a cube, you would go b over x minus 1 to the first, c over x minus 1 squared, and then d over 1 over x minus 1 cubed. That's all we're doing. Nothing crazy. That's the rule for case 2. Okay. No questions so far? Setup makes sense? Case 3. So this is distinct quadratic factors. So when you cannot factor it, it's irreducible, then you have to do a different rule. Can you guys see okay? Or does it need to be brighter? Okay, I'm gonna assume it's okay. All right. So x over, this time I'm just gonna go ahead and factor it for you. So this cannot be factored further. X minus 1 is already a factor. X squared plus x plus 1 is irreducible. There is no way to factor this. So you have to leave it like that. Okay, so what you do, you treat the first one like you do on case 1. You just put the a over that one. It's just a distinct linear factor. Who cares? But when you have something like this, you have to do bx plus c over that nonsense. So it's a special rule. Just when you see something you can't factor and it stays a quadratic, do this. Case 4. This is when you combine rules 2 and 3 together. Repeated quadratic factors. So I'm going to go ahead and give it to you already factored. So notice that this is something that does not factor but it's repeated. So you're going to count up until 2. So you use the same quadratic form, ax plus b, or rule, I should say. So that's the first one, and then second power, cx plus d. Okay, so those are the 4 cases. The next case is the annoying one because it requires long division. This is my least favorite. I'm sure it will be your least favorite as well. Any questions on 1 through 4? Okay, you cool on this page? I will be scanning this at the end of class and uploading it, but if you're following along writing, that's fine. Just let me know. You cool if I turn this page? There's no rush. Okay, let me know if you want me to turn it back. Case 5. I was going to shorten it to improper fraction. So when you have an example like this, you see how the top is a cubic degree and the bottom is a quadratic degree. So when the degree of the top is higher than the bottom, you have to do long division. Okay, before we do algebraic long division, do you remember basic long division? Because that rule, that algorithm is going to be important. So let's do it on the side over here, just in case. Just to refresh ourselves. Let's say I'm dividing 5 into, I don't know, 595, right? 5 goes into 5 one time. So step 1 is use this to divide into the first term. 1 times 5 is the next step. And once you've multiplied that, you put a minus. See how the sign switches to opposite. 5 minus 5 is 0. And then you bring down the 9. Right? 5 goes into 9 one time. 1 times, and then you repeat the pattern. 1 times 5. So this pattern is what we need to remember. Then we bring down the 5. 5 goes into that. So see how it just keeps going. So that's what we're going to do. It's a little different, but it's very similar. So this is dividing into this here. So you're not going to divide with the whole thing. You're only going to divide with the first term here. But when you get the result up top, you will multiply everything. Okay. Now, actually, 1 second. 1 moment. Sorry, somebody blowing up my phone. I was like, what the hell's going on? Sorry about that. So before you start, there's something I forgot. You need to add every degree. Notice how I have a cube, but no square. Then I have a first power and a constant. So I have 3, 1, 0, but no 2. So you need to put in a placeholder or else you may mess it up. So put plus 0x squared. plus x minus 2. So now I have 3, 2, 1, 0 degree. Okay, or power, sorry. Now, let's start. This is how you do it. I'm going to do it over here on the side somewhere. Scratch work. It's going to be a lot of scratch. So x squared goes into x cubed how many times, right? Just like we did 5 into 5. We got to do the work. Let's do it over here. X cubed divided by x squared. That's just x, right? See how you divide? X cubed divided by x squared is x. Okay, so that's the first step, right? 5 into 5 is 1. X cubed into x squared into x cubed is x. Now multiply x times all of these terms. I'll do that over here. X times x squared plus x minus 2. That will give us x cubed plus x squared minus 2x. So that result will go down here. X cubed plus x squared minus 2x. Now that result, remember how we got the 5 earlier, 1 times 5? Then you need to switch the sign. So you're going to put minus. So this minus is going to swap all your signs inside, right? So x cubed minus x cubed, that's going to be 0. 0 minus x squared minus x squared. X minus minus 2 is plus 2. And then bring down the minus 2. You guys see where these terms came from? So basically, so remember, let's show the sign swap.
I'm sorry, where are we getting the -2 at the end? On the for the like, cause it starts out with +3, and then in the problem it's -2. Like x cubed minus x plus 3, and then inside it says x3 plus 0x squared plus x minus 2.
How about this part? X
No,
squared.
So
Here.
for the denominator is x cubed minus x plus 3, which is what's inside. But it's x
Yes.
cubed plus 0 squared plus x minus 2.
Oh, I see what you're saying. Yeah, this should be, I don't know where that came from. That's a good question. Let's fix that before we get too, I'm so glad you told me at the beginning, because that would have sucked if I found that out like 10 steps later. Thank you so much. So that should be minus x plus 3. So this should be a 3. And this would be minus minus, so it'll be 2 minus x, and it'll be just a single x. Let me write this better. There we go. Okay, so now where did this come from? Let's go through that real quick. So minus all these terms is going to give us this, and that, right? Sign swap. So this is being combined with this first row. So x cubed minus x cubed minus x cubed is 0. 0 minus x squared is a negative x squared. Negative x plus 2x is a single x. And then the 3 just comes down. Okay. So you can swap all the signs here if you like, and then do it. I just want you to see that this minus is part of the pattern. Okay. there any questions on this step? Before we, so that's the first iteration, right? 5 goes into this 5 1 times 5, we subtracted, now we got, now we bring down the 9. That's where we are now, that 9 part, the second iteration of the division. So now x squared will go into negative x squared. That's what we're going to do next. It goes in there negative 1 times. Negative 1 times all this stuff will be negative x squared minus x plus 2. But then you have to swap the sign, you have to subtract. So you can do the subtraction over here. It'll be x squared plus x minus 2. Okay, so negative x squared plus x squared is 0. X plus x is 2x. 3 minus 2 is a 1. And now I can no longer go any further. This only goes, this does not go into x. So that's my remainder. Any questions on this? I mean, if you haven't done this in a long time, or if you've never done this, it'll take you a few tries, or a few examples. Okay. So don't feel bad if it's weird. The first time I did it, I was super confused and I hated it. And I never used it until Calculus 2. So that's when I had to learn it. It's also helpful in, of course, this section. Anyway, the remainder. So do you guys remember how to write a remainder? Right, this is my quotient, right? The remainder should always be written over the divisor. So that when you divide this, it's going to equal this quotient plus the remainder. So instead of trying, so now you apply partial fractions to this guy. These two are good, these first two terms, but this is the part that needs partial fractions. So those are the 5 cases. Now, if you're wondering what the heck is a partial fraction and why are we doing this, this is the reason. All right, so basically, it's saying that if you have a fraction that's has 2 factors in the bottom, you can separate them into into a sum of each factor. So instead of dealing with one fraction that has a product, you can separate them into a sum. So there exists some a and b that will make this equation equal, make it true. And the next step, the next thing we're going to do is learn how to solve for a and b. Okay. The first thing is, can you use case 1 through 5? And once you set them up, can you solve for a and b? Okay. Any questions on the cases? Case 1 through 5. All right, let's go start over. Look at case 1 and solve it this time, not just set it up. You guys cool on this page? Remember, this is called long division. If you want to see more examples, I'd say just, well, you can always come see me during office hours, but I would also YouTube a couple examples just in case you don't remember long division. Okay. I will not be putting one of these nasty ones on the test, by the way, but they will be on your homework. I don't like these, but but I think it'd be a really mean test question. All right. So let's actually do example 1. The questions will say decompose, and it'll give you a partial fraction, or sorry, a fraction. Okay. So we did this earlier, and then we separated it into these two terms, right? So now I'm going to show you how do you solve for A and B. This is a distinct linear factor type, case 1. So you separate it this way. So step 1, multiply both sides by the LCD. X plus 3, x minus 2. So you multiply both sides so every single term by that LCD. Now, the left-hand side is always going to completely cancel, leaving you with just the numerator. So we don't have to show this step every single time, but I'm going to show it here. Now, this one will cancel one of them. This will cancel that other one. So that will leave us with x minus 2 times A plus x plus 3 times B. Okay. So step 2, we're going to use the technique equating the coefficients. Coefficients. To solve A and B. All right. So this method we're about to do works every single time. There's another method that works sometimes, which when it does work, it's a lot shorter. But when it doesn't work, it's a pain. It's a real pain. So I'm going to show you the technique that always works. So distribute the A and distribute the B. Then group things that are the same type, the x's and the constants. So ax and bx and 2a and 3b, these are constants right here. These are linear factors, linear terms, I guess I should say. Ax plus bx minus 2a plus 3b. So this is called equating the coefficients because you can factor an x out and a plus b is your coefficient. You see what I mean? So you equate this coefficient to the left-hand side to the coefficient of the x on the left-hand side. Do you see an x on the left side? There's none, right? So this a plus b is equal to 0 because there's a 0x over there. So this coefficient equals the 0 coefficient. These constants equal to this constant. Does that make sense? It's a 2, by the way. So that's what equating the coefficients means. You create a system using the coefficients, and you equate them to the other side of the equation. Any questions on where this came from? Is that clear? Okay, I assume it makes sense. So at this point, you just solve the system. You can use a matrix, or you can use substitution or elimination. I don't really care what you use, just solve for A and B. You can use a matrix and a calculator if you want. I'm not going to require work for this piece here, solving for A and B, because it's a pain. I mean, this one's not that bad. But let's say you had A, B, C, D, then that's going to be a real pain. And I don't want you to do that. So the A column is 1 and -2. So that's the coefficient of the A's. The B column would be 1 and 3. Do you guys remember anything about matrices back in college algebra? But this is my A column and my B column. So you take the coefficients and you put them here. 1 and -2. 1 and 3. Okay, that's all you have to do. Oops, I forgot piece though. Now, you augment it. This is called an augmented matrix with 0 and 5. So you can punch this in your calculator or whatever, and you can solve it. You can also use an online solver, which I'll show you right now. Let me see. 1 second. I don't know. One moment. Okay. So you actually, I don't know this, but yeah. So I'm going to allow Desmos on your exams. So you don't, that way you don't have to use a graphing calculator. So there's the link to Desmos, but I'm going to show you on screen share. So let me do this again. So you hit new matrix. Let me clear all this first. Start over. To create a new matrix, I need 3 rows or 3 columns. Enter the matrix we created: 1, 1, 0, -2, 3, 5, and hit enter. So now A has been saved. So click RREF and then click A, and that'll solve it for you. So this is the solved matrix. Let me write it down. This is called row reduced echelon form from back in college algebra. I'm not going to make you do it by hand because that was very difficult back then. We can just use this solver. Okay, so now what does this mean, right? Do you remember how to read this matrix? Right, so if you put this back into equation form, this is telling you that this column is the A column, right? This is telling you that A is equal to -1. And this row is telling us that B is equal to 1. So it solved A and B for us. So we didn't have to do any substitution or elimination. We just get the numbers into a matrix and solve it on the calculator. If you want to do elimination or substitution, that's fine. I'm not going to tell you which way to do it. Just give me A and B and put them up top and you're done. Okay. So our answer, just plug in the A, will be -1 over x plus 3 plus 1 over x minus 2. So this is my answer using the A and B. The matrix is the easiest way to do it. On this example, it would have been easy to do elimination because it's a very small system. But as soon as you get C's and D's, you're going to want to do this. That's my recommendation. Do you have any questions on this example? Either middle, beginning, or ending? I don't know. It's all good. You see how it's pretty algebra heavy, right? Right. Well, I'll move on. I'm sorry. Go ahead.
So is A -1 because the first row was -1 and B is the second one because it's on the bottom? Okay, just wondering.
Yeah, this is kind of like saying, so I mean, let's think about it. A plus B equals 0. So we got a 1 plus 1 equals 0.
Oh, okay.
So this is saying A plus 0 is equal to -1. In other words, A is equal to -1.
Okay, no, I get it now. Thank you.
Mhm. Okay, and again, you don't have to use a matrix. You can do elimination if you want to. This is my suggestion. Any other questions on number one before I solve number two or case two? Okay. Decompose 2x minus 3 over x cubed minus 2x squared plus x. And we factored that into earlier, 2x minus 3 over x times x minus 1 squared, right? That's what we did. Case two. Now we said that this was a repeated linear factor, and these two are distinct. So we ended up with a over x plus b over x minus 1 plus c, and then we counted up to 2. You guys remember? So we did. So remember what I said, right? Setup is majority points. We just set it up right there, or at least 50%. Now the rest is solving for ABC. That's the next part. Okay. So step one, we said multiply both sides by x times x minus 1 squared by this LCD. That's always going to be the case. You take this thing on the bottom, on the left side, multiply every single term. And if you multiply on the left, we said that it's always going to give you just this top part. But let me show you an in-between step before we do that. Okay, so take this guy times 2x minus 3 over x times x minus 1, and then multiply that same thing times each of these. So we said that this will cancel every single time, leaving you with this. Then you multiply each single term, right? Just distribute it. You're going to get, I'm going to show all these little steps for you, just in case. Oops. Should be a times C. Oh man, hand's cramping up. All right. So this will cancel the x. This will cancel one of these. This will cancel the entire thing. So I'll be left with 2x minus 3 equal to x minus 1 squared times a plus x times x minus 1 times b plus cx. Okay. So at this point, we have canceled all fractions. That's why we're doing that. Forgot to write step 1 here. Dang it. Sorry about that. It looks a little messy. It's just too many terms. So again, just to keep it all together, we took this denominator and multiplied every single thing by that. That's all we did. That will cancel all fractions, leaving us with this. So this is the messy work in between. But essentially that is all we did. So step 2, equate the coefficients. So you're gonna have to multiply that out. So that'll give us x squared minus 2x plus 1 times the a. Multiply this out, that'll give us x squared minus x times the b plus cx. So if you multiply this twice, you're gonna get this. If you distribute the x inside, you're gonna get this. Are you guys okay with me skipping that algebra step, or do you want to see the details of how we got here? From here to here. Want to see it? Okay. 1 second. All right, so x minus 1 times x minus 1. And then the age right there. Distributing this into each term will give us x squared minus x. And I just leave it there times the b. We'll do that in the next step. Multiplying this out, x times x is x squared, x times negative 1, negative 1 times x, negative 1 times negative 1. There we go. So you're just foiling it out, basically. That makes sense. You can also use a formula to skip from here to the answer, which will be this right here. This is what I prefer to do because I don't like to work harder. Just want to get it done, right? So there's a formula that says if you square a binomial, you can go straight to here. That formula is this here. If you have 2 terms being squared, it will always be this. Okay, so a and b are x and negative 1. That gives me this. Okay, any questions on the algebra steps here? Is that okay? All right. So now distribute the a and the b, and then start grouping things that are the same power. Right. To distribute the a inside, a times x squared, a times 2x, a times 1. So these 3 came from b times x squared, b times negative x, are these 2. And that's just there. Then I group everything together, and then we start making the system, which will then create the matrix, if you choose to solve it that way. But since we have a C, we for sure should, because I don't want to be dealing with, we're going to have 3 equations. Solving 3 simultaneously can be challenging. Matrix solves that problem for us. To group all the quadratics together, group all the x terms together, group the constants. It's only one, right? Just the a. So equating, we said if you factor, you get this, a plus b. You factor this guy, you're going to get negative 2a minus b plus c. That's the coefficient of the x term. So basically you factor the x out to create a giant coefficient. This is just some number like 7. I don't know what it is. It's some number. This is some number. Okay, so you equate the right-hand side to the left-hand side. Do you see any quadratic terms on the left? Right, there's no quadratic, right? So you're going to say a plus b is equal to 0 because there's nothing there. Then you look at these 3. These are the x coefficients. We do have an x, right? So set this to 2. Then constants, a to this guy. Does that make sense? Do you see what equating the coefficient means? Any questions on any of this before we start creating the system?
Can you go over one more time? You said equating the coefficients.
Yeah, so what you do is you group anything that's the same power, right? So here are the quadratics, here are the x's, here are the constants, right? So you factor that quadratic piece. So this part is my coefficient. This is my coefficient. This is by itself, who cares? So you equate this one, a plus b, to the quadratic term on the left, but we don't have one. So you say a plus b is equal to 0. Then you do this, set this.
Equal to 2.
Yeah.
Okay, okay, I get that now.
And then the constant equal to constant. If there was more than one constant, you would put all of them together, equal to -3, but we don't have any. Now here, we don't really need a matrix, it turns out, because we have A, which means we can solve B. And if we have A and B, that means we can solve C. But if we were to use one, I'm going to show you how to set it up. Do you see how we have A's, B's, and C's now, right? There's going to be 3 columns for the coefficient, and then a 4th column for the equal to part. So we'll do the A column first. We have 1A in the first equation, -2 in the second, 1 in the third, right? Now we do the B column. We have 1B in the first equation, a -B in the second equation, no B's here, so 0. Now the C column. There's no C's. There's 1 C, no C. And then the equal to part, 0 to -3. So I just punch in the calculator and you're good. Any questions on creating the matrix? Do you see where A, B, and C came from? These columns. Okay, so let's go to the calculator and solve it. I'm not gonna do that by hand. Not about that life anymore. Selling that by hand would probably take like a page, so I don't recommend it. Okay, new matrix. We have 3 rows and we have 4 columns, right? So 1, 1, 0, 0, -2, -1, 1, 2, 1, 0, 0, -3. Enter. So now it's inside the memory. So if you hit REF, this solves matrices for you. Row reduced echelon form. Put in the A in there. There's my answer. So A is -3, B is 3, C is -1.
When I go to Desmos, it doesn't, which calculator do you, or which option do you choose when you're in Desmos doing this?
Click matrix calculator. You see it?
Yes, thank you.
Okay. So we have A, B, C to just plug them in to the answer. So we've now found the ABC that makes this equation true. So we've decomposed the fraction into a sum of 3 different fractions. That's what we're trying to do here. So that is my answer. And again, I'm gonna be honest with you, this process is not useful until Cal 2. So if you're not going that far, you'll never see this again after this class. Partial fractions, I mean. It's a random section we're required to cover before the pre-cal begins. So if you will get it out of the way first, get the weird section out of the way first. Okay. Any questions about this example, beginning or middle or end? Doesn't matter. Okay. Yes, cool on this page. I'm going to turn to case 3. Okay, one moment. All right. Case 3. Example 3, I guess. Decompose this guy. Into partial fractions. Okay. So step 1. Well, first we set it up, right? So we did earlier. So X, we had to create the equation. Smeared it. So we said that if it's irreducible, if it's linear, we just do A, right? If it's irreducible, you use BX plus C or AX plus B, depending on what letter you're on. That's all you got to do. Okay, so step 1. Multiply both sides by the LCD. So left-hand side times this nonsense. And then these terms by the same thing. I'm going to leave it in parentheses because I'm running out of space. So left-hand side is going to cancel, right? Completely gone, leaving us with just the X, just the numerator. So multiply these two on each of those fractions. That'll give us X minus 1 times X squared plus X plus 1 times the A term, plus the same nonsense times the BX plus C. Right? So this will cancel that guy. This will cancel that one. So X is equal to X squared plus X plus 1 times the A plus X minus 1 times the BX plus C. Right. Any questions on step 1? Is that clear? Give me 1 second. I'll let you catch up on the writing. I'm going to get a quick drink. 1 sec. All right, so now step 2 starts. We equate the coefficients to start to create the system. So distribute the a, and you're going to get a x squared plus a x plus a. FOIL this out, more multiply, however you want to think about it. X times that guy. X times that. -1 times c. I keep writing my b's like d's. Biscuits. Okay, so everything's good now. That should be a square though. X times bx, x times c, -1 times. Shoot, messed that up. I'm sorry. There we go. Okay. So now group everything together that has the same power so we can equate the coefficients. Quadratics, x's, constants. That's an A, by the way. Okay. So x is equal to a plus b plus, actually, there's nothing else. A plus b times x squared plus a minus b plus c times x minus c. So first equation, equate the quadratic. So what is a plus b equal to? You see there's no
0.
Yeah, 0. A minus b. What about the next one? The x coefficient.
One.
Yeah, it's 1. Negative c. There's no constants, right? Zero. Okay. So now just make the matrix. So A column, there's 1A in equation 1, 1A in equation 2, no A's in equation 3. 1B in equation 1, a negative B equation 2, no B's equation 3. No C's in equation 1, 1C, -1. Equal to 0, 1, 0. So we'll solve this on your calculator. Make life a little easier. Because this has enough steps as it is. I don't want you doing more. So please use a solver. Unless you like to suffer. I don't know. All right, so we got 3 rows and 4 columns. 1, 1, 0 equal to 0, 1, -1, 1, 1, 0, 0, -1, 0. RREF, the matrix we just made. It looks like A is at 1/2, B is -1/2, C is we already knew was 0. So A is 1/2, B is -1/2, and C is 0. So just plug them in and you're done. This is what you'd plug into your homework, this little piece right here. 1/2 over x minus 1 plus -1/2 x. There's no c, so just leave it alone. X squared plus x plus 1. Doesn't look very pretty, but that's what it is. Now, when you're doing your homework, they're going to show you a different method. It's called the, well, when you know how you hit like, help me solve this or something. You guys familiar with that, right? They're going to show you using a Heaviside method. And again, I told you that method works some of the time. This one works all the time. Ideally, you want to know both, and you use them when you use the Heaviside when it's best, and then you use this one when you have to. But if you don't want to have to learn multiple techniques, that's up to you. But you'll notice that on some of them, that method that they use, it seems very easy, but then later it turns out to be super hard. So keep that in mind when you're doing them. Okay. I'm not gonna force you to do it one way or the other. I'm telling you to use what you want. I'm recommending this one. Okay. You guys cool on this page? Okay. Is this making sense? You guys doing okay? Do you have any questions? Okay, let's go. Let me go ahead and open up the homework so you can see it. Okay, so this is your homework. It starts out with some definition stuff, which I'll let you work on. And then here it starts trying to test you on, do you know how to set it up? Which is the first thing we did. Okay, so check it out. We have two distinct factors, right? Which answer would you choose? There's no work to be done, just set it up. What do you guys think? This is case one. See? We have three terms, but we only have two factors on the bottom, right? Yeah, it has to be A, right? Has to be. Surprisingly, they gave us three that don't make sense. So it's going to be A over the X term and then B over the X minus 4 because they're both linear and they're different. They're distinct. So this is case one. It should be right. About 95% sure that's right. This guy has a repeated factor, right? So this would be case two. So remember how we said when it's repeated, you count up until that number. So has to be B, right? 1, 2, and then X minus 4. So A over that, B over this, C over this. Right, we did this almost the same type of example earlier, except our square was on the second part. Is that clear? This is the one we did. Which answer is this one?
D.
Yeah, it looks like it's gonna be D because it goes 1 and then 2. So this is how you deal with repeated. Repeated meaning you have a power of 2 or more. So 1, 2. And the X is just a single power, so you just put an A over it, right? So that's the setup. This one can be factored. So you would first factor it and then begin. Like we did the first question on the examples. Same thing here. These after problem 6, they start having you factor before you begin. And then when you get to 9, you start doing the entire thing, which is what we're doing right now. You set it up, you factor, you set it up, and then you begin the process, solve for ABC, whatever we got. Okay. 15 and 16 suck. This is the long division. Anyway, we'll stop here as far as lecture goes. Do you guys have any questions or concerns or anything that didn't make sense along the way? You guys have any technical problems with your homework stuff? Everything working?
I saw 5 different cases. Would we cover more of the cases? Like, will they only show, or I'm sorry, maybe I'm confused.
There's only 5 cases. Yeah, we set up all 5. And we solved 3 of them, but the solving part is the same every single time. The setup is the only thing that changes. So make sure you get that setup down before like the first 8 questions. Make sure you get that down before you start doing number 9 and etc. Any other questions? All right, guys, I'm gonna scan these and upload them in a few minutes. Video, I'll email you the PDF and the YouTube link about maybe in 30 minutes or so. Okay. Did everyone set up Remind at this point? I might just dump it in there. Yeah, just set up Remind when you get a chance. It looks like there's a few missing, maybe 3 people missing. I guess, well, I'll see you on Wednesday if you have no other questions. And if you do, feel free to stick around for a bit.
Thank you.